mechanisms for polarization, and I will just get started. Oops. So this talk, as Nina mentioned, in 2019, I published this book with James Owen Weatherall, The Misinformation Age. And what we do in there is use a combination of approaches. So we look at a bunch of historical case studies, then we look at a bunch of agent-based models to try to understand some of the factors that lead to the propagation and continuation of false beliefs in human groups. And then since then, we've sort of continued with that sort of work and have a co-administered NSF grant where, with collaborators, we work on sort of similar modeling work looking at the spread of false belief. So that's the kind of context of the big project where everything I'll be talking about is part of that project. So the models I'm talking about today all look at polarization, and I want to flag that I'm talking about a particular kind of polarization here because this is a term that people actually use to mean a lot of different things. But I'm going to be talking about situations where members of a community stably adopt diverging or disagreeing beliefs about matters of fact. So a lot of polarization people talk about has more to do with what we might call values or opinions, sometimes normative or moral values. This is about when people just disagree about the truth of something. And this occurs in a lot of real world situations, including sometimes in cases where there's ample evidence available to decide the issue. So just to give a little example relevant to the US context, there's been widespread disagreement in the United States about whether there was voter fraud in the 2020 US election. So this is a highly polarized topic. People disagree about the answer to this question, even though there's plenty of evidence to show that there was not, in fact, voter fraud during this election. So that's the kind of thing that these models will be addressing. Here's the plan for the talk. So what I'm going to do is talk about 3 different models where this sort of polarization is a possible outcome. And each one of these will suggest a prima facie plausible explanation of real world polarization. It will show, okay, here's a way you can generate patterns that look like the polarization we see in some communities. And then what I'll do is finish by discussing, well, okay, well then what can we infer from these models and from the fact that you can take a single phenomenon and model it in a bunch of different ways like this. What can this sort of model do for us epistemically? What can it tell us about the real world? And throughout, I'm going to use a particular methodology. So I'm going to look at agent-based models from what we can call the network epistemology framework. And in each project, what we do is take an epistemic network and then add some social or psychological feature. Sorry, here's my dog. And then each project shows how just adding this feature alone can shape learning outcomes. And each project shows in particular how polarization emerges. So it's kind of a light switch causality picture where you have a model without this feature and you don't get polarization, then you add the feature and you do. And as we go along, it'll be more clear what these models actually look like. So here's a roadmap. In part 1, I'll talk about the sort of base model framework that I use throughout this project, the network epistemology framework. Then in part 2, I'll give the first polarization model where I talk about how a particular kind of trust dynamics can lead to polarization. In part 3, I'll talk about how conformity bias is a sufficient cause for polarization in these models. In part 4, I'll talk about confirmation bias, not to be confused with conformity bias because it's different, and how that can lead to polarization. And then in part 5, we'll have like a little bit more of a higher level philosophical type discussion of what does this mean epistemologically for how we think about using models to look at polarization. So part 1, network epistemology. Okay, so this framework was first developed in economics by two economists, Venkatesh Bala and Sanjeev Goyal. And they developed it to think about social learning and learning in groups. And then the framework was imported to philosophy of science by Kevin Zollman, who used it to think about the formation of consensus among scientists in a community. And that sort of came to us by way of Kevin. So these models involve two basic elements, a decision problem and a network. And the decision problem is a representation of agents trying to figure out something about the world. And the particular one we use is called a multi-armed bandit problem, where the idea is that there are different options you could take that have different success levels. And it's supposed to be analogous to a bandit or slot machine with two different arms, where the arms could pay out at different rates. And what you're trying to do is figure out which is the better one. So in our particular model, we'll say, okay, there's two actions, action A and action B. They succeed at different rates. And for simplicity's sake, we'll say, okay, action A, which we'll call the all right action or arm, that's your mnemonic, A for all right, is successful half the time. And then action B, which we'll call the better arm, is successful more than half the time. So 0.5 plus epsilon % of the time. But the agents in the model are going to start off unsure about whether B is in fact better or worse. So the thing they're trying to figure out is, okay, which of these actions is the most successful one? So that's the problem. And then what I'll describe next is how they go about figuring out which is the most successful one, how things change, or the dynamics of the model. So at the beginning of any simulation of this model, we say, okay, we're going to have some agents and we'll give them random credences about whether B, the better action, is in fact better. So if Nina's credence is 0.6, she thinks there's a 60% chance that B is better than A. So all the agents get a random credence of this sort. And then we run simulations where over successive rounds, they actually test the arms. So they test the arm by taking the action they think is better some number of times. So if Nina thinks B is better, she actually tries out B and sees what happens. If Tobias thinks that A is better, he tries out A and sees what happens. And then after seeing their results, they update their credences using Bayes' rule. So they use normative rules of rationality to change their credences based on their results and also the results of their neighbors. So that's where the network aspect of the model comes in. They're on a social network where they're linked to other agents, and any agent they're linked to, they also see what that agent has done. So for example, if I'm linked to Tobias and he tries B and he gets sort of bad results, it doesn't look good, my credence goes down. I think, okay, it's less likely that B is the better arm. So that's the base model. Maybe I should, so just to kind of review, what we're modeling here is we have a group of agents. They have social connections between each other. They're trying to figure out like some options in the world, what's better. They do that by testing. They test what they tend to think is better, and then just keep kind of updating their credences and testing again. So what this could represent maybe is something like doctors who have two different treatments for some disease and are trying to figure out what is better. And the only way to actually find out what is better is to see what happens when patients try those different treatments. Or it could represent a situation where A, some people think that smoking is safe, and B, some people think that smoking causes cancer. And the only way to know whether smoking causes cancer or not is to actually look at what happens when people smoke. So what happens in these models is that communities tend towards consensus. They tend towards states where everyone agrees about which action is better. And this happens because of this social influence between agents. So if there's some agent who's testing B, their neighbors are seeing those results. And over time, if enough time goes by, they're going to come see that B is better than A, and then they're going to test B themselves, and then their neighbors can see this. And so you have these processes by which everyone comes to hold the same beliefs. So usually what happens is that all the agents converge to high confidence in the better action B via this process. They come to a true consensus about the world. Though sometimes they all erroneously settle on the worst action A. They all think smoking is safe. And this can happen if, for example, there's some early string of results that is spurious, that suggests that B is bad and A is better. That string of results might sort of convince everyone in the network, okay, A is the better action. And once they're convinced of that, they stop testing their other alternative, in the same way that a scientist might stop testing a theory that doesn't look promising, or individuals in a community might stop trying an action that looks like it's not successful. Okay, so that is the whole setup for the base model. So now let's talk about the first polarization model we build using this setup. So this is actually published work. So we published this paper, Scientific Polarization, and this model is drawn from there. And what we do is we take this base model and we make a key alteration, which is to assume that some agents are more likely to trust evidence, assume that all agents are more likely to trust evidence that comes from someone who holds similar beliefs to them. And this matches empirical observations about people. This is something humans tend to do. So if Chris and I have the exact same credences, we entirely trust each other's evidence and we update fully on it. As our credences diverge, we become less and less trusting of the evidence coming from the other individual. And we point out in this paper that when we think about scientific beliefs, matters of fact, this kind of behavior is at least somewhat reasonable. So I wouldn't want to say like this is rational with a capital R, but I'd want to say it's a kind of justifiable behavior, because we generally think that we shouldn't trust data coming from everyone. So in particular, you shouldn't trust data shared by someone who's known to be a quack, known to be a poor epistemic agent. And so there's some kind of reasoning where if you're an individual who trusts your own reasoning abilities, you might deduce, well, people who have very different beliefs or opinions from me must be doing something wrong, and therefore they must not be trustworthy epistemic agents. And so I should discount the kinds of evidence they share with me. So we give a case study in this paper as well of an instance where we think something like this is happening in an actual scientific community, which is in the debate over chronic Lyme disease. And the debate is whether chronic Lyme disease is a real disease and whether it needs to be treated with long-term antibiotics. And on the two sides of this debate are groups of actual medical practitioners, some of whom think yes, some of whom think no, and where there's a huge amount of mistrust between these two communities, to the degree that they often entirely discount the kind of evidence and studies coming from the other group. All right, so that's the idea behind this first model. And we do this in particular by saying, all right, so we're going to have this trust that drops off when agents' beliefs diverge, and we'll just do this as a decreasing function of the distance between their credences, and then we'll scale this by a multiplier. So, as our credences go further and further apart, trust goes lower. We can make that drop off steeper or less steep. And then we kind of operationalize trust as how much I treat your data, how skeptical I am of your data having occurred. So if I fully trust you, I think this is definitely real data that was gathered from the world. If I don't, I start to think, well, maybe this data is real, maybe it's not. And so I update less strongly. And for those who are familiar, we use Jeffrey conditionalization to do that. All right, so what happens in this model? We find that when we make this alteration, there's now a new possibility for the model. So as long as there's just a little bit of mistrust, all the simulations still converge to consensus. These were the same outcomes that you could have in the base model, so either true or false. But when we get more mistrust, we see polarization emerging. And these are stable outcomes where some of the agents have very high credences, they think B is better. Some have very low credences, they think A is better. And because their credences are so divergent, they do not trust any evidence coming from the other community. And this means in particular that the A agents never see the evidence that B is better, or they just don't trust that evidence at all. And so they never actually start to explore whether B might in fact be better. So this is a figure showing that finding. So on the x-axis here, we're increasing mistrust. Mistrust is going up. On the y-axis, we're saying, well, how often does polarization happen? So these are models where we look at a bunch of different parameter values, different network sizes, different values for how successful the B arm is, a bunch of different things. For each set of parameters, we run a simulation, 1,000 times and ask what outcomes do we get? And one of the outcomes is polarization. So this is showing how often that happens. And there's this straightforward relationship, more mistrust, more polarization. And you can see for larger networks, you get a bit more polarization than smaller ones. And that's just because if you have a bigger group, the chances that someone's kind of on the other side are higher. So that's the sort of first thing. We also find that in general, mistrust in these models increases the average amount of false belief. So here we're increasing mistrust on the x-axis, and then each little point here is one parameter value for our models. And we ask, how many false beliefs do agents have on average for that parameter value? And we see this very straightforward trend where more mistrust, more false belief. And that's happening basically because, these A agents who end up polarized and believing in the false thing, when they're mistrustful, stop paying attention to good evidence that would change their minds to something more accurate. So takeaway here, as I said, there's at least something reasonable about individuals who are skeptical of people who have reached different conclusions, hold different beliefs from themselves. But we can show that in this kind of model, global skepticism hurts the knowledge producing capacity of a community and is a sufficient cause of polarization. So what I mean by sufficient is that adding it into the base model allows for polarization, take it away, it doesn't. We show that kind of relationship. Good. So part 3, let's talk about conformity. So this is also from published work, this paper, Conformity in Scientific Networks. Now, starting with the famous Ash experiments in the 50s, it's been widely documented that humans have tendencies towards social conformity. And in this experiment, what they would do is they would show subjects one line of a certain length and then 3 lines of different lengths and ask which one matches. And they'd have a bunch of confederates of the experimenter give the wrong answer first. So a room full of people would say, I think it's line 1, I think it's line 1, I think it's line 1. And then you'd get to the experimental subject and they'd be able to see it's line 3, not line 1. But they'd have to choose at that moment, am I going to conform with everyone else? Or am I going to state the line that I can tell is the correct one? And they found that about 1/3 of the subjects would just conform with what the rest of the group was saying, even though the direct evidence of their senses says that that's wrong. And this study has since been replicated widely across different cultures and different contexts with different details. So this is, a stable tendency in humans not to like sticking out from a crowd, not necessarily to like doing things other people aren't doing or saying things other people disagree with. So we add just this tendency to the base model. And what we do now is take the model and add a conformity parameter, K, which tracks how much payoff actors get for matching the behaviors of their network neighbors. So they ask, all the people I'm connected to, what action are they taking? And then they have some preference to match those actions that can be stronger or less strong. And they're weighing two desires in this model because, of course, they still have a desire to choose accurate actions. So in the base model, actors take the action they think is better, but then they also have a desire to conform with their neighbors, and they can scale between these. So, the question for each agent is something like, how much do I value payoffs from the world versus social payoffs? So again, adding this conformity parameter, and I should be absolutely clear, this is social trust is gone. So now we're back to the base model plus just conformity, means new possibilities for the model. So it's still the case that we can get the old results, that you can get true consensus or false consensus. Now you can also get outcomes that look like consensus, but where some actors secretly disagree that the apparent consensus is the correct one. So you can have an outcome where everyone's doing the worst action. They're all smoking, say. There are some agents who secretly think this is worse. They secretly think, well, maybe smoking is dangerous. But because they prefer to conform with their neighbors, they never actually switch actions. And so nobody ever gets more information about the action that's not being taken. And then we also get a possibility for polarization of a different sort, so via a totally different causal pathway. And this can emerge in models where you have clique structures. So by a clique structure, it's probably intuitive what that means, but it's something like, if I have two friends, they have an increased likelihood of being friends with each other. So you have tightly knit in groups within your social network. And when that happens, you can have a global network where some cliques are all doing action A, others are all doing B, and then conformity is stabilizing these choices. So that could look something like this. You have one group of individuals who all think B is better and they all take action B. One group who all think A is better and they all take action A. They're connected to each other, but this individual, so they see the evidence from the wider community, they actually come to think B is better, but because they're conforming with this group, they don't switch actions. And if they don't switch actions, no one else in this group ever learns about action B because they only see things about A. And so you have a stable, polarized situation. Good. So the sort of main results we find is that when you have more conformity, you have fewer accurate beliefs and more polarization. So this figure is a little complicated because there's 5 outcomes for the model, correct consensus, incorrect consensus, and then consensus with some doubters, and then polarization. But basically the picture here is on the x-axis, we take conformity up. We look at how often you get the different outcomes. And we find that the incorrect actions go up as we get more conformity, and polarization goes up as well. So takeaway here, conformity plus certain network structures, these clique structures, provides another sufficient cause of polarization generated by a different causal pathway than the social trust pathway. And this happens, as I said, because those who conform can fail to pass along good information to others. And this can lead to what we might call information bottlenecks, where someone has a better belief, but they prevent their neighbors from ever learning about it by conforming. And as we point out in this work, while realistic social networks do have cliques, this is a basically ubiquitous property of human social networks. And so conformity possibly might help explain some real world polarization. All right, good. So, I'm going to do the third model, but I can mention we have We also talk about a case where it looks like conformity probably played a role in this way that I described, like an information bottleneck. So this is a painting of Lady Mary Wortley Montagu, who was a British aristocrat. In the early 18th century, she traveled to modern day Turkey, where she encountered the practice of variolation, which was pretty common there, which was a kind of like a vaccination for smallpox. While there, she and her personal physician worked with a Turkish nurse to variolate her son against smallpox. Then upon returning to England, she tried to spread the practice and met a lot of resistance from English physicians. And there are, various reasons why they might be resistant. They haven't heard of this. It sounds like maybe sort of a weird practice. But in particular, it seems like conformity to the group was preventing the spread of this good practice. And part of the reason it seems like that is even her personal physician, who had already performed a variolation, who had seen widespread evidence that it was safe and effective, was unwilling to perform them once he returned to England and was sort of under the eyes of other British physicians. Good. So with that, let's talk about part 4, confirmation bias. So this is collaborative work with Nathan Gabriel. Nathan is currently a student in the Logic and Philosophy of Science department at UC Irvine. And he did almost all the simulation work on this project, the model building, and wrote the first draft of this paper. So he did a lot of the heavy lifting here. And this paper is in, we just got it into final draft form, so it's up on meta-archive. So if you want to check it out, you can check it out there. Can confirmation bias improve group learning? So we've talked about 2 factors that can act as sufficient causes of polarization. These 2 previous factors regarded social connection. So social trust is about the relationship between your belief and another agent's belief. Conformity is about the relationship between your action and another agent's action. But we can also ask, how do individual reasoning biases function in a social setting? So how do biases having to do with the way that I, as an individual, react to evidence function when I'm learning in a group? So that's what we're doing here. And we're looking at confirmation bias, which actually refers to a set of related biases where individuals tend to be more receptive to evidence that fits their current beliefs. And so they could be more receptive because they seek out evidence that fits their current beliefs, because they avoid people who share evidence that doesn't fit their current beliefs, because when they hear evidence, they update differently on it. So there's a number of different ways you can do this, and our model, as you'll see, fits with some of them. This is a little cartoon about it. Here's someone who says, "I've heard the rhetoric from both sides. Time to do my own research on the real truth. Literally the first link that agrees with what you already believe, jackpot." So this would be an example of the kind of confirmation bias where you go seeking evidence that's going to fit with what you believe. So now we alter the base model in this way. We say, upon receiving evidence, so I get a packet of evidence, I calculate my prior likelihood that this evidence obtained. So I have some credence that B is better and some credence that A is better. I use those credences to say, how likely would this data be given my prior about the world? Then once I have that likelihood, I can kind of scale it with a multiplier, and that gives me a probability of updating on it. So if I think data is quite likely to have obtained, I get a higher probability of updating on it. If I think data is less likely to have obtained, given my current beliefs, I have a lower probability of updating on it. So that creates a way to make agents more likely to update on evidence that accords with their current credences. So if I think B is definitely better and I get evidence where B was very successful, I'm more likely to update on it. So here's our first result, which was kind of a fun modeling result because it is not what I expected to happen. So Nathan was working on the grant and I said, well, why don't you try adding confirmation bias to these models? It will make the agents worse at learning. Our first result was that it actually makes the agents better at learning, a moderate level of confirmation bias. So here's a figure where we look at networks of different sizes, larger or smaller, and we ask how often do they get to successful consensus. And for higher levels of confirmation bias, they're more likely to reach successful consensus than for lower levels of confirmation bias. Why would that happen? So what happens in these models is that confirmation bias acts like a kind of stubbornness where agents don't change their beliefs very quickly, and that prevents them from prematurely locking into a suboptimal theory or practice. So as I said earlier, the failure mode of this kind of social model happens when some spurious results are widely shared and everyone rejects the better option. But when you have confirmation bias, people are slower to reject anything. And so you tend to have a longer period of exploration where both theories are being tested. And that longer period means that agents tend to have more time to develop good beliefs about both theories. And this relates to a result from Kevin Zollman, who found that in the same sort of model, more disconnected groups sometimes do better for the same reason, because there's less social influence between them. And so they spend longer exploring multiple theories. And that means that they tend to get to the right one more. So that's our first result. It's kind of fun. But that is for models where agents never entirely discount information. So when I described how confirmation bias works in those models, there's always going to be some probability that an agent updates on any information. It might be very small, but there's a chance that they will update on it. So we also looked at models where we removed this feature. We said if there's very disconsonant data, an agent entirely discounts it. They just say if this data has less than whatever, a 10% likelihood for me, I never update on it. And when we have that kind of cutoff treatment of confirmation bias, polarization becomes possible and epistemic outcomes are typically worse. So what this shows is that when we have a cutoff of this sort and we make that cutoff higher and higher, we get more and more. So this shows the three outcomes for the model: correct consensus, incorrect consensus, and polarization. We get more and more polarization. And as a result of that increased polarization, as this cutoff gets higher, this shows like how often agents get correct beliefs. They eventually start to have incorrect beliefs as a result of strong confirmation bias, because you once again end up in situations where you have polarization, you have a group of agents who think, okay, A is better, even though it's not, and they're ignoring data showing B might be better. And as a result, they never are going to develop accurate beliefs. So takeaway here, confirmation bias may have epistemic benefits at lower levels in a group setting, sure, surprisingly. But if we look at a more robust form of it, or sort of larger amount, it's again a sufficient cause of polarization and again can hurt the knowledge producing capacity of a group. So we have our third sufficient cause of polarization, yet another distinct causal pathway that can lead to polarization about matters of fact. Okay, so what do these models tell us? What do we do now? So I'll flag first, there are more ways to generate polarization over matters of fact in different sorts of epistemic models. So you can have a model where you have different areas of social network where people aren't gathering their own evidence, but they're just getting sort of information from outside sources, and they're just paying attention to different information sources. So this would be a model where maybe one group is listening to one news station, another group to another news station. They get systematically different information, and that stabilizes their different beliefs. You can have models where everybody is fully rational. They're all full Bayesians, but they hold different meta beliefs. And by that, I mean something like scientists can't be trusted, so that upon receiving the same bit of information, their beliefs go in different directions and then they polarize that way. You can have models where agents disconnect from social partners who hold different beliefs. So this is kind of like the social trust model where they don't trust other partners with different beliefs, but you can say, instead of mistrusting, they just cut off their network ties. Now they never encounter these agents. And this relates to what people call echo chambers online, where people seek out groups that have consonant beliefs to their own. You can have models where people are getting data via algorithms, and those algorithms only share confirmatory data with them, share the kind of data they like to see. And that relates to the idea of filter bubbles online. So here's another 4 mechanisms for factual polarization that I'll throw out there. So general takeaway, there are a lot of sufficient causes for polarization. There are a lot of ways to get polarization over matters of fact. Obviously, that means that if we show a sufficient cause in a model, that doesn't definitively tell us what causes polarization in any particular case. It doesn't even show us that what we see in the model ever causes polarization in the real world. And you see in papers where people model polarization, inferences like this. Well, there's polarization in the real world. I've shown how you can get it in the model. Therefore, the kind of theoretical framework I've developed here is a correct way to understand the world. But obviously, we should not be reasoning that way, given that we have all of these different sufficient causes for polarization. Now, that said, I still think these models are worth building, and I still think they're epistemically useful. And I think the first reason is that what you can do with these models is identify possible causes of polarization that you can then go explore empirically. And sometimes a possible cause of polarization is kind of intuitively obvious, and sometimes not. Sometimes possible causes aren't accessible or obvious without modeling tools. And so using models to get kind of hypotheses to test can be quite useful, I think. I think these models also support a more complicated picture, which is something like this. In any real world case of polarization, you might have multiple interacting causes at play. And if we look across different cases of polarization, they might be caused by different things. They might be generated by different causal pathways. So even when you have situations where you get an approximately similar looking phenomenon, you don't know that the things causing that phenomenon are the same things in these different situations. And so again, you're going to want to use empirical study to try to get at what's happening in any case. And so I think in both of those 2 ways, the models improve our ability to investigate polarization using empirical tools. I think they also give a cautionary note. So they say, we don't want to just trust sort of simple unitary explanations of polarization or policy interventions intending to act on these sort of very simple explanations. Because we've got these multiple, potentially compatible, sufficient causes, it's not clear that giving any one explanation is going to suffice in any case. And if you go from like, well, conformity can cause polarization, so let's try to decrease conformity in social networks. Targeting a single cause like that could very likely fail and may even backfire if it unwittingly amplifies another mechanism while suppressing others. So for example, if you think, all right, everyone's conforming, what we should try to do is connect people in different clique structures with each other, and that'll decrease polarization. If these people also don't trust each other, it's not going to work, right? Because they're still not going to update on each other's evidence. And in fact, you could have kind of negative effects where people are now coming into contact with those they disagree with and don't trust, and you just more friction. And so policy proposals should be sensitive to this situation, should think about possibly complex interactions between different causal factors and what might happen from intervening on any single one. All right, so we're almost done, but I will throw in one more little thing for those who are interested in philosophy of modeling. These are examples, these models, where idealization and abstraction are improving the epistemic power of the model. So often people will say something like, when you do a super simple model of a social situation, okay, the model is missing a lot of stuff, and your ultimate goal is to put all that stuff in to build a more complex model that's closer to reality. But in a case like this, if you toss everything in, you cannot generate understandings of causal sufficiency. So if I have a model with social trust and different information sources and conformity and confirmation bias and algorithms, I don't know from that model what things do and don't cause polarization just on their own. And so I don't actually get very good causal control of these different factors. You need the simple model to get that kind of theoretical understanding. Good. So to wrap up, models identify multiple possible causes of polarization over matters of fact. And I talked about 3 that we've worked on: social trust, conformity, and confirmation bias. These factors may also hurt the epistemic capacity of a community. Untangling which are relevant in any case is an empirical project, but one which is helpfully informed, I think importantly informed, by modeling work. So with that, I will say thank you.